All right, well, good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's DevOps.com webinar, brought to you by Techstrong, AWS, and ClearScale. My name is Cody J. Brown. I'm the host of Techstrong Learning, and we've got an exciting presentation for you today. First, I do have a couple of housekeeping notes to cover. So today's event is being recorded. So if you miss any of our discussion, or you'd like to rewatch or share with a friend, the on-demand recording will be made available shortly after we conclude our live session today. If you have any questions for Anthony, we do want you to go ahead and send those in to us using the Q&A tab, which can be found on the right side of your screen. This is also where you're going to find the chat tab. That's where we want you to engage with your fellow audience members. Let us know your thoughts throughout today's program, or maybe just from where you're tuning in. We do have a couple of polls that we will be launching throughout today's program, so please keep an eye out for those, as we do want your feedback. And we will also have some discussion over some case studies. And if you wanted to follow along and read those case studies, they are available in the handouts panel for you. So feel free to download those at your own leisure. And of course, before we close, we will be giving away 4 $25 Amazon gift cards, so be sure to stick around. Our topic today is optimizing cloud-native app development with containers. And I'm joined by Anthony Loss, Senior Solutions Architect at ClearScale. Anthony, thank you so much for being here with me. I'm going to let you take it from here.
Sure. Great to be here. Thank you, Cody and Techstrong Group. Today we have a very interesting topic, and I'm excited to get into it. Containers are one of my favorite things to talk about in all of the cloud world. I'm going to get to a little bit of introduction on myself first, and then I'll dive into the topic today. And it looks like we got people from all over the world, and that's so cool that you guys are tuning in here. If you have any questions, just go ahead and throw them in the chat, and I'll address those when I can. Okay, so a little bit about myself. I am a lead solutions architect here at ClearScale. For those of you who don't know who ClearScale is, we are an advanced AWS Premier partner. We're an AWS Premier partner, not advanced, which is one step higher. And we are an all-in AWS services firm. So all we do is focus on AWS. We don't focus on any other clouds. And we're super excited to be partnered with Techstrong and AWS to deliver this conversation about containers. And so myself, more specifically, I have been an AWS architect for a little over 7 years now. I've been focused on AWS for, like I said, a little over 7 years. I've been in the IT industry for about 9 years. So as you can tell, you can probably tell that majority of my career is AWS focused. And that's both a gift and a curse at the same time. And so, over the years, I've had to broaden my knowledge in, what Azure is doing and what Google is doing, and some of the other public cloud providers, OpenStack, things like that. So we're going to get into a little bit about containers today. And so more specifically, containers on AWS. But, first we're going to talk about what containers are. Before we dive into specifics of AWS and AWS offerings, I want to talk about what containers are as opposed to some of the more legacy compute that you guys may be more familiar with in the past. I got to comment, believe it or not, there's a much bigger world outside or AWS. Yeah, there is. There's a much bigger world. And so, we'll talk about that here as well. So just quick touch on ClearScale again. So we are, a premier tier services partner. We've been in the AWS Partner Network for over 10 years. We have 11 AWS competencies, and you can see them, a little bit of them on the right here. And so we really focus on modernizing our customers in AWS. Obviously, a lot of customers are migrating to AWS, but our expertise, along with migrating, is modernizing, and that kind of brings us to the conversation here today. So today's agenda, like I said, we're going to talk a little bit about containers, what they are, how they're used, why they're a differentiator in the space, and then we're going to get into some use cases of containers. After that, we're going to do some exploration on getting started with containers on AWS. And then we're going to finish off with some customer case studies that we've done here at ClearScale. And then obviously I'll open it up for questions at the end. So we have a poll before I even get started. So Cody, if you would throw up a poll and see what answers we get here. Go ahead and answer that if you can. Give about 20 more seconds here. Okay, some answers are flooding in now. All right. So I'll talk about this a little bit now as the answers are still coming in. What is your current container usage? Right now we have about 35%. We use containers on-prem and in the cloud. Now just jumped to 38%. And I find that very interesting because most of the customers that I talk to either use containers on-prem or they use containers in the cloud. And so it's interesting that we have a little bit of both here. And I can address that in a little bit and some of the differences there. Yeah, not many folks are using containers just on premise right now. Probably because you can't explore all of the benefits of containers on premise. You're limited to your hardware on prem. And about 28% don't currently use a container. So this will be a good conversation topic for you guys too. Okay, awesome. So just a high level overview here. Why modernize applications? Well, let's talk about why folks are going to the cloud first. If you're going to AWS or any really public cloud for that matter, and you're treating the cloud the same way you're treating your colocation or your private on-premise data center or wherever your servers are, then why are you in the cloud? The main purpose of being in the cloud is to modernize and become cloud native. And when you're becoming cloud native, you're using native tools in the cloud, specifically for AWS. They have a ton of native tools, and you're lowering your total cost of ownership. You're getting to the market faster. You're developing quicker. You're more focused on your applications instead of your infrastructure. You have distributed workflows, so less tightly coupled workflows, and you're obviously infinitely scalable, right? And as you're infinitely scalable in AWS, as your business grows, you can explore more options to scale, and you can explore more options for savings plans, savings costs, reserved instances, so on and so forth, in order to be as cost efficient as possible in the cloud. So if you're in AWS today, or you're considering going to AWS, it's very important that you have a roadmap to modernize as well, because just being in the cloud is not really, you're not taking advantage of it. You're doing yourself a disservice. And so we'll talk about, how to modernize and why modernize with containers right now. So I'm sure we all have our own, thoughts about what containers are. And to me, containers are packaged applications. That's it. They're an application and dependencies that are packaged together in order to deploy certain parts of an application. So containers were initially developed to package application with its dependencies. So that's the configuration files, that's interfaces, that's libraries, and it's all deployed in a single image that you can move successfully between hosts and between application decoupling. Okay, they isolate applications, right? Execution environments from one another, allowing the operating system to be decoupled as well. They're dynamically divided from each other. And in reality, if you've heard the term microservices, containers are microservices. So yes, it's not just serverless architectures that are microservices. It's actually containers, which are much more powerful than what you might know as serverless architectures such as Lambda, even though Lambda has a ton of good use cases, right? Even with containers, just a ton of good use cases. If you have more powerful workloads and you want to continue or modernize to microservices, containers are exactly that. They're microservices because they are loosely coupled, and you can change your application development based on a certain part of an application. And I'll get into that here with the benefits of containers. And so once again, the main key I want you to take away from what containers are is that they're packaged applications with their dependencies in that package. So once again, it's configuration files, interfaces, libraries, different dependencies, right? And a lot of times, defining an application can be difficult because it can mean so many things. But a lot of times when we say packaged applications, it could be a certain part of an application. So if I have a SaaS product, right, so software as a service, maybe an application is the contact form for us to get in touch. And maybe, it's a dynamic contact form. You want to be able to have a development team to just focus on that. And it has a different library, different dependencies. Then that's one container, as well as the actual other parts of the SaaS application, maybe another container, so on and so forth. And you put all those together, that's a workflow. And that's a distributed workflow. And so it's a good segue here into the benefits of containers. So with the containers, you have more of an opportunity to focus on building the application and spending less time managing the compatibility requirements of different environments. So let's take a step back here. Let's go back to the year 2000. In the year 2000, or maybe 2005, in the year 2005, you had physical servers. And typically, you had one application, large application, monolith application on one physical server. And you had stacks and stacks of servers. You had server racks. Servers were doing different purposes. And there's a very monolith architecture because everything was really, really dependent on each other for the entire system to work. So if you had one component failure, you had an entire system component failure, right? An entire workload failure. Then in around 2008 or 2009, we got this introduction to this cool new thing called VMware, virtualized environments. And so essentially what that is you take that physical server and you divide it among virtual servers on that host. So now you have virtual machines with an application per virtual machine, and you're having a more loosely coupled server environment, right? So you have different virtual machines on the same server doing different things. And that was a huge breakthrough. And many customers today are still using VMware, Microsoft's version, Hyper-V of virtualized servers. Great. Both of those are fantastic in splitting up your server virtual environment to do certain things. Now, it's even a step further with containers. So you have your virtual machine, but it's not necessarily one monolith system per virtual machine. It's taking the different dependencies of application workflows and splitting them up on a virtual machine. So just expect one layer higher. And when you have multiple tasks or containers all on one virtual machine, many virtual machines all on one physical server, okay? And so that's really what containers are doing. It's another step towards microservices, and it's another step towards letting your development teams, as they may differ, focus on their specific component, as they may have different skill sets than other developers in your environment to build applications. So for example, let's say I have a development team. Let's say I have two development teams. One development team likes to build dependencies with NPM, and the other development team likes to build dependencies with Yarn, right, for the application. Now, in the past, everything had to be dependent on each other. So you had to pick one, and then as you guys were to develop new application features, you had to check with the other development team. They had to be in sync. A lot of times there would be miscommunications and component failures, which would in turn be a workload failure. Now with containers, each part of the application has completely its own environment. And so you can have a development team that likes to do certain dependencies and libraries, while the other development team can do other dependencies and libraries and never really have to communicate with each other because they're hosting their own image. Now, obviously, communication is key amongst every business, but it's a more loosely coupled architecture. And so for component failure, right, this is where we're focused on component failure. So previously, even with virtual machines, if you had a major failure in a feature of application, the whole workload would fail, usually, depending on your application. Most of the time, the entire workload would fail. Now with containers, if you have a different feature for container or a different application for container, and there was a failure, it just focuses on that component. So usually the other workloads, the other tasks of that application as it's in entirety can still function. And that way you're able to pinpoint the component failure, and you're able to control the failure to minimize footprint. And it's very, very important as we build more complex applications. We have streamings, we have virtual realities, and there's so many applications that customers are developing nowadays, and it needs to be loosely dependent. And so developers are actually experiencing this phenomenon in a shift. It's known as a shift, where they handle quality control up front rather further down the line in the development process. So that's why they're creating these images, and we'll get to that in a second, without relying on each other. And so that's super important. Okay. When to use containers? We'll dive into this. Primary uses of containers, in my opinion, you should always be working towards containers, no matter what the application is, or what you're trying to do. I mean, unless it's like an extremely simple application where containers can be a little bit overload. But all your production applications, you should be thinking about a container roadmap down the line. If you're not thinking about a container roadmap down the line, I promise you your competitors are, and they're going to eventually be more performant and more flexible and faster to market than you. So it's very important to have a container roadmap down the line, for when you want to modernize containers. So what's good primary use cases for containers? Usually, and a lot of folks don't even know this, is that it's good for third-party applications and utilities. So with containers, you can actually pull from public registries. AWS has its own public registry, and it's all packaged. So you can pull a component or a task from a public registry of a third-party made image, and you don't have to worry about developing all the dependencies or libraries incorporating this or that. You actually pull that and plug it right into your workload. And that's really, really important for time to market, right? There's a lot of applications that want to use certain components of a third party. And how do they do that? Well, you got to buy licenses, you got to figure out how to deploy it and add the necessary libraries. There's a PDF document with 100 pages on how to do it, so on and so forth. No, that takes a long time. That's legacy thinking. Now with containers, we can pull that. We can pull that from a public registry, plug it right into our application. All the dependencies and frameworks are within the container image. We're ready to go. Another reason, and AWS might be mad at me for saying this, but I'm going to say it anyways because it's to your guys' benefit, is that containers can be cloud agnostic, which is super important. So you have your container image, and let's say, for whatever reason, you want to move from public cloud to public cloud. Instead of having an environment that's tightly coupled to a certain cloud platform, your container can be mix-matched in different public clouds. And that's super, super important for enterprise customers as they need to be able to plan for any type of public cloud change. And that's why you're seeing a lot of enterprise customers and large applications being built on containers, is so that they can be agnostic in their environment. As long as they have Docker or Rancher, which we'll get into in a second, they're good to go. And both of those can be on AWS or any other public cloud platform. And so coming back to the comment earlier, which I completely agree with, there's a much larger world outside than AWS. You're absolutely right. And this is why containers are a good solution, is to be able to deploy applications in microservices to different environments. A primary use case for containers as well is to start developing and testing as soon as possible. So if you have a deadline where you want to come out with a new feature or a new application, and you need to start testing and developing as soon as possible, once again, containers is great for that because it's less startup time. You can pull starter images from public repositories that have all the basic libraries and frameworks that you need to develop your application. So your developers can just focus on application code as opposed to doing all the little dependencies and frameworks that they have to do for every single application. It takes time, it takes a few days, it can take a few weeks to be able to make that work. Well, now with containers, you can pull that stuff, or you can copy container images and start from there. So it's much, much faster. different environment dependencies for different parts of workloads. So obviously, if you have a use case for containers, some parts of a workload may have a different dependency than other parts of a workload. Let's just get back to our NPM versus Yarn or wherever the libraries may be. Maybe there's different dependencies, but your whole workload shouldn't be centered around the same dependencies, as that's not truly microserviced. So containers are a good use case for different environment dependencies for a different part of workload. Okay. So this is actually, I didn't even know this, and I think it's a good thing to call out. But 80% of all containerized applications running in the cloud actually run on AWS, according to Nucleus Research. And so I explore you to know about that, and we'll get into why we're seeing a lot of containers on AWS in a second because of the offerings. But this kind of goes back to that initial poll where we're asking, hey, if you're having containers, where are they running, or you do not have containers? And that's why I find it interesting that a lot of you guys have containers running on-premise and in the cloud. And I have so many questions on why. It may be you're transitioning to the cloud and it's taking some time, or maybe your on-premise environment for certain containerizations is needs to be on-premise for compliance reasons, or whatever the case may be. And so if you're thinking about using containers in the cloud or migrating the rest of your containers in the cloud, I would really consider AWS for some of the reasons I'm going to get into here in a second. Primarily, though, because AWS is focusing almost all of its efforts on containers that are loosely coupled from licenses and different dependencies. And so that's really, really important. That's why we're seeing so much growth on AWS for containers. So choosing your AWS container service. We'll get into these in a little bit more here in a second, but there's basically 3 container services within AWS. And I want to make sure that when you guys leave this webinar, that you have a good understanding of what these services are and how they differentiate from each other. Okay. So you have Amazon ECS, which is short for Elastic Container Service. And what this is it's a Docker-based workload. So you have your Docker images. It's based on EC2, which we'll get into more here in a second. And it's highly customizable, highly customizable. You can choose different instances, different compute, so on and so forth. Then you have Amazon EKS, which is Kubernetes-based. And for those of you who are familiar with Kubernetes, you'll know that the Kubernetes open source library is full of different customizable plugins, right? You have your Kubernetes control plane. You have a ton of customizable plugins for your images, and you can do a lot of things. And if you're familiar with Kubernetes, which a lot of customers are, they usually want to stay on Kubernetes. And so that's why Amazon has Elastic Kubernetes Service, which is a managed service for managing the the Kubernetes control plane here in a minute. So you can have that ecosystem of Kubernetes open source library, the plugins, so on and so forth to be able to manage your Kubernetes environment. And so most of the time when we see a customer migrating to AWS and they have containers, like some of you guys now, if they're using Kubernetes, they want to stay on Kubernetes and they want it to be deployed to EKS. When we have a net new customer migrating to AWS, or net new customer that's in AWS and thinking about modernizing their workloads, most of the time they're going to choose ECS because it's a little bit more simple. They're a little bit simpler with Docker than opposed to Rancher. And we'll get into that here in a minute. And you could still use Docker with EKS, but essentially the simplicity and the documentation for ECS is a little bit more than EKS because EKS is so broad and you can do a ton of stuff with EKS. And then finally, there is a serverless offering for containers, in which I find really, really neat. They have a ton of pros for this, but there's also some cons that I want you guys to be aware of if you're thinking of serverless containers in AWS. It's called AWS Fargate. And so essentially, as you all know, serverless, right? No servers to manage. You only pay for the resources that are used as demand spikes. It's a managed service. You'll use more tasks, which are containers. in Fargate, and then when it goes down, automated service lowers the tasks, lowers the compute, so on and so forth. Fargate can support both Kubernetes and ECS. So you can use Fargate ES, Fargate ECS. It's a really, really cool tool within AWS, and I'm excited to tell you the different components of it. So there's a lot of things you have to keep in mind when getting started with containers on AWS or really any cloud. And so there is the provisioning part, orchestration, security, networking, automation, and monitoring. And for our talk today, we're going to talk a lot about provisioning, orchestration, security, and monitoring, just because we have so much time today. And essentially what I want to talk to you guys about is the build environments for containers, image repositories for containers, some security that goes around with that. And then lastly, and one of the most important things in my mind is the monitoring that goes around with that. So let's look at basic container architecture. When I first started learning about containers, it all made sense to me conceptually of why containers are being used and why the shift towards containers. But then I had to dive deep more in and say, well, what's the architecture? How does it actually work? What's the underlying services within containers to make it real decoupled? Like what's behind the curtain with containers? Is it all talk, or is it really doing what you say it's doing? And so we'll get into that right now. This is a very high level architecture of containers. And as you can see here, this is ECS based. And so ECS based, you can also even think of it as EKS based. And the difference between that here in a second is that you have container instances. So these will be EC2 or virtual machines. If you go back to what I was saying earlier, in that middle layer of virtual machines that are hosting the different services and the different tasks. And you might be saying, well, Anthony, I don't see any containers here. You just have container instances, services, and tasks. Well, the actual containers are the tasks. Those are the decoupled parts of the application with the libraries that can perform certain functions as it relates to microservices, right? So you have your service within your container instances, and then you have your different microservices of tasks to be able to perform certain functions within the application. And so that this is really, really important, because you might have a component failure, which may be a certain task which fails, which a lot of times keeps your application up and running because it's decoupled with the other tasks as it's a part of that service. So you can think of the service as the workflow and the tasks as the microservice applications. Okay, let's dive into this in a little bit more detail. So once again, this is a basic container architecture, and I apologize if it's a little blurry, but I wanted to make sure I showed you this image because it's a step further than the previous image that I showed you. So once again, this is a ECS cluster, which you can also think of it also the EKS cluster would be pretty similar except for one key component, which we'll get into that here in a minute. But you have your EC2 instances, and within those you have your different services. And within those, you have your tasks, in which case you can put your containers in, right? And so as you see here, you have your service A, service B, and service C with your different tasks. Now, let's pretend I have a number of development teams. And as I said before, different tasks can have different dependencies and libraries. And so maybe a development team consisting of 2 or 3 people only have certain skill sets and certain libraries and frameworks in order to deploy an application. Well, this is why containers are so great, because it's decoupled from the rest of the infrastructure, okay? Different tasks and different services ultimately make up one large workload. So even if a service fails with the different tasks inside of it, the service B and service C oftentimes are used in redundancy for the application, can still be up and running. And able to serve your customers, or depending on what the application does, your employees, or so on and so forth. And so this is very important for the architecture. I want to see if there's any questions on the basic architecture of containers. I'll give it probably 10 seconds from now. I know we're a little bit of a delay. Awesome. So I must be doing a good job. We get some radio silence. So, if you have any questions on, the architecture, please feel free to throw them in the chat and I'll get to it as soon as I can. But yes, so this is the basic architecture of containers. This is not a serverless architecture. This is the more, it's a server architecture with ECS and EKS. This is the main architecture of any containers, whether you're running them on-prem or you're running them in AWS. Obviously, the differences there are the manageability of those containers, but this is really important to understand as a conceptual base. This helped me really learn what containers are and what they're doing. Now, a lot of customers who are migrating to AWS have questions around, hey, should we, or modernizing an application in AWS, should we use ECS? Should we use Fargate? Or should we use Kubernetes? And I'm going to go into some of the pros and cons and the architectures of each here. It's very important as you're modernizing your application to understand what the key differences for these services are and how to apply them towards your application. Maybe some applications are better run on Fargate. Maybe some are better run on ECS or EKS. It's also important to understand is that you don't need to pick one container service and go all in on that for all your applications. You can mix and match for these things. And that's the fun thing about AWS is that you can have a very flexible, very dynamic workload in order to be able to apply this. So I got a question in the QA here. Can you explain what the relationship between container and microservices are? Yes, I can. The relationship is that they're the same. Containers are a microservice. If you have multiple containers, then you have multiple microservices. And so you'll hear the term microservice throughout, throughout the industry, right? There's a lot of buzzwords in cloud. And so when you hear microservices, think of an application that has different functions of the application that are independent of each other. And so that's really what microservices are. You have a workflow or an application, and different functions of this application perform in different ways. And that's really what containers are doing, because you might have a large workflow and containers are performing certain functions of that workflow that are independent of each other. So once again, if a component fails, the whole workflow doesn't fail. Or if you're making a feature update, you don't have to update the entire workflow. These are services within services, which are microservices. Okay. So Amazon ECS, Elastic Container Service. One thing to understand about Amazon ECS is that they're Docker-based. And so when you're Docker-based, that means that the managing platform for your containers is called Docker. And so when you're running Docker in ECS, you have that management platform, and Docker is managed for you within ECS. Now you still have to manage the compute instances, and so excuse me. And so when you have ECS, it's very customizable. So you can pick your container instances based on how you need your compute. Or let's say, I have a certain container instance that I have a bunch of containers on there that need to be GPU optimized. Well, that's great because you can pick your certain EC2 types, just like you would pick any EC2 instance in AWS to be able to host your containers on, right? So once again, the EC2 instance is the virtual machine, and you can really get customizable with which virtual machine you want to use to help support the containers that are sitting on that virtual machine, okay? And so maybe different container instances or virtual machines, EC2 instances, have different purposes, and you have 4 or 5 containers for that purpose that need to have more heavily compute or more memory optimized, right? And so ECS allows this sort of customization to be able to really, really deploy containers in your own way. Now, there are some cons when it comes to ECS and EKS, you're responsible for managing those EC2 instances. So just as you would have virtual machines in AWS with EC2, you have to manage the patching, security patching. You have to manage the instance management. If there are failures, you have to make sure that you have your disk images backed up in order to put those operations in control. It's more hands-on management of the virtual machines, not the containers, the virtual machines that are running the containers. So the same type of management that you're doing in EC2 is stuff that you have to do within ECS. So if you think ECS, think ECS with EC2. Now, obviously, we'll get to Fargate here, which is a sub service of ECS without EC2. But most of the time when you're hearing ECS, when I migrate to ECS, when I do this in ECS, you're still using EC2. You're just using containers with EC2. We have a couple questions here. How does Kubernetes tie in with containers? So we'll get into that here in a second. But Kubernetes is a platform service. And so Kubernetes is an open source software that allows different libraries and different plugins that are Kubernetes compatible to work with your containers. So sometimes you may have an application that has a plugin that's only specific to Kubernetes. The way I like to think about this is I'm a little bit of a gamer, and I like to think of PlayStation versus Xbox, right? And that's the way I like to think of this stuff. So Kubernetes, you can imagine, is Xbox. And so different games are available in Xbox than they are in PlayStation, right? So different plugins are available in Kubernetes as they are in Docker, right? Or Rancher or Docker. And so that's what Kubernetes is for, is to be able to service different workload plugins or different workload architectures than you might be able to get with ECS. I have a general question about containers. It seems like there would be some problems with different containerized applications working together. Well, yeah, I mean, that's very possible, right? It's important to, when you're architecting these applications, it's important to understand that, yes, they are loosely coupled, but just like an NFL football team, all the players need to do their job in order for the team to win. Or all the players need to stay healthy in order for the team to win. Now, the team can still function if they're not doing their job. They just won't function at the highest level. And so in order to, if you think about that back into containers, in order to have the most achievable output with containers is that they need to be in sync, right? Especially if it's a part of one distributed workflow. And in order to do that, you do need to have smart architectures with that. And this is why a lot of companies are not necessarily, if they're not container whizzes, they're hiring companies like ClearScale or AWS, other premier partners, to be able to help architect and help deploy these containers in a way that is accordance to best practices. So yes, I mean, with any workload, there's a chance of failure. But containers are mainly focused on keeping that failure within a component as opposed to an entire workload failure. Okay, let's jump into Fargate. So AWS Fargate, this is where we're getting serverless. And this is where it gets super, super interesting. So a serverless platform within Fargate, you have your different tasks within a service platform. So now you're not managing EC2 instances. You're just managing your containers, which a lot of customers are moving towards managing just containers. They want to get out of the infrastructure business, right? And so AWS Fargate allows this to happen. It's extremely flexible. It's a managed service, so it scales. It scales up, scales down. It's stateless, meaning that whenever I see stateless, I think brainless. So it doesn't have to be super knowledgeable about other tasks or other hardware that's maybe in your environment. Or, like I said, it's even more loosely coupled than ECS because you don't have to manage the infrastructure. One thing to understand about AWS Fargate is that it's serverless. So the storage on these instances that you don't have access to is ephemeral. Because you're not managing the underlying server like you are in ECS EC2, the storage for your tasks, right, on that instance are ephemeral. So if you shut down a group, an AWS service within EC2 Fargate, and you're not backing up those storage or the local storage on those tasks, then they will be deleted forever because they are ephemeral. And that allows, the reason why this is because it allows Fargate to launch and scale different EC2 images in the background, right, that you're not managing, which is still serverless, without having to worry about being tightly coupled to a storage service. And so just remember, AWS Fargate local storage is ephemeral. And so as you design applications and architecture for Fargate, make sure they're really, really loosely coupled and they're not dependent on its local storage. There's also limited customization of compute. So if you remember in ECS, you have your EC2 images, and those EC2 images, you pick GPU optimize, you could pick memory optimize, maybe a T instance, maybe an M instance, however you want to pick your container instances. With AWS Fargate, that's all managed. So you don't have access to the underlying virtual machine. And so you can still pick a category of how you want your compute to be, but it's very, very limited. And once again, AWS does this so that you can have more of a decoupled workload, more of a distributed workload. So you're not depending on so much of an instance to be high powerfully in compute, because once you have more of a dependence on a certain instance with a bunch of tasks, the more chance there's a failure and your entire workload goes down. And so that's why people are choosing Fargate. Even though there's less customization of compute, that really shouldn't matter because we are splitting up our tasks as it's appropriate to feature-based. Okay, so there are some pros and cons of AWS Fargate as well as Amazon ECS. All right. Now let's jump into EKS, Amazon Elastic Kubernetes Service. This is obviously focused on the Kubernetes workloads. And the main difference between EKS and ECS is the managed Kubernetes control plane. And so if you've ever worked with Kubernetes in the past, everything happens through the control plane. This is how you manage your workloads, you manage your tasks, you manage your containers, so on and so forth. The control plane, if you have it on-prem or if you have it not in EKS, can be difficult to manage because there's your underlying hardware, you have your dependencies, your libraries, so on and so forth. And so Amazon packages all this and you manage your Kubernetes control plane right through the Amazon console or through the CLI in order to manage the tasks or containers in your Kubernetes environment. Right, obviously some pros in this is Kubernetes in general. You have tooling and plugins developed by the open source community. That's what's so great about Kubernetes is that there's constantly being, developers from all over the world are constantly putting in new libraries, new plugins, new tools, enhancements, thought leadership into the Kubernetes open source community. So you can get super customizable with your application. And obviously you want to be familiar with the different complexity of Kubernetes. That's why some customers don't go there because they're not familiar. But if you were to choose, in my honest opinion, if you were to be, choose, if I'm going to go in all on containers and choose, which service to go with, I would try and learn Kubernetes and go with EKS because of all the fun, customizable images that you can make for Kubernetes and your environment. All right. Container images with ECR. So Elastic Container Registry is a service in AWS that allows you to store your personal container images for the build process. So you can control, who has access to those container images. You can update container images through code pipeline, which we'll get into here in a minute with one of the customer case studies. And so it makes it super easy to deploy images per tasks. Let's say task B uses container registry image B, right? And so I can deploy to that task with the image that we have with all the required dependencies, libraries, application code, so on and so forth. Think of them as machine images that you have with EC2, right? So I can deploy these repository images for certain tasks in order to expedite time to market. So while your production workloads are running, you can have your developers come up with new container images and deploy that to ECR, and then eventually deploy that to your tasks. So it's super, super helpful for that. And like I said, you can control access to who can see the images, or maybe you have a repository image just for production and a repository image just for dev, and so on and so forth. Okay, so I encourage you to take a look at Amazon ECR, Elastic Container Registry, and how that works. Remember that it's private, so it's applicable to your business. Monitoring and logging, which is super, super important with any workload, let alone just containers. And so the cool thing about monitoring and logging is that there's different ways to do it. Now, I'm sure most of you have heard of CloudWatch. And CloudWatch comes in a variety of different flavors, right? You have CloudWatch logs, you have CloudWatch agents, metrics, CloudWatch subscriptions, CloudWatch events, so on and so forth, right? And so when you're managing ECS, the couple ways to do it, they have log drivers for ECS to automatically put logs into your CloudWatch logs, but you can also deploy a CloudWatch agent on the side of each container. This is known as a sidecar. So think of a motorcycle, and then the sidecar of someone riding next to the motorcycle and just riding there, right? That's exactly what's happening with deploying a CloudWatch agent for monitoring and deploying logs to Amazon CloudWatch logs for each container. So you can deploy CloudWatch agents as sidecars for each task to push logs to a centralized logging service in order to query and analyze those logs. CloudWatch agent's good for ECS. Log driver is another good one. EKS, you have FluentD or FluentBit to be able to do this. Those are native EKS tools in order to, once again, take the logs from the Kubernetes containers and push them towards CloudWatch logs. And when we get into CloudWatch logs, now we can do all sorts of fun stuff in order to deploy that. Fargate, you don't have to worry about this. Fargate's managed. Remember, you're not managing the underlying container instances. So Fargate automatically puts the logs in CloudWatch logs. So you don't have to worry about installing the agent, being customizable, so on and so forth. Because Fargate, you don't have to manage the virtual machine or the EC2 instance. It takes care of this for you. Another reason why customers like Fargate. With any workload in AWS, security is key, right? You want to encrypt, you want to have encryption at rest, you want to have encryption in transit. And so whether you're using Fargate or ECS or EKS, the encryption at rest is super important. And oftentimes customers use, for encryption in transit, they use a load balancer. AWS has a service called Elastic Load Balancer, in which case you use SSL or TLS with that, and the SSL certificates retire on the load balancer, and then the load balancer directs traffic towards the underlying EC2 images in a private subnet that don't have public access. Now, what if you say, well, Anthony, my service is SaaS-based, so I need public access to be able to host my applications, right? Because it's public, it's a website, or it's a SaaS offering, or so on and so forth. Well, that's fine. A couple ways of doing this. First way is you can have a reverse proxy. A reverse proxy is a container instance in a public subnet that splits the difference between the load balancer and the container in a private subnet. So, for example, the proxy, just as a proxy does, takes all the traffic information from outbound, communicates it to the underlying container instance, and then spits it back out in a very expedited way. This is also known as a sidecar. Right? You can have a sidecar of your application in a public subnet, and then the meat and potatoes of the application in a private subnet in order to hide the IP address of your actual containers and your tasks. A lot of customers are using sidecars with Nginx or just a totally different Docker image, wherever the case may be, to handle that intersection between. You don't have to use a sidecar either. You can put the entire meat and potatoes of the container into a public subnet. You can retire SSL instances at the container level or at the service level, and I'm sorry, at the EC2 level for the services, and just work from there. Or you can still retire the SSL certificates into the load balancer and then feed the rest of the traffic and just assure that all traffic is going through the load balancer. Number of ways to do this, right? AWS Fargate, as that memory is, remember the storage is ephemeral, but it's automatically encrypted. For ECS and EKS, it works just as Elastic Block Store. Remember, because you're managing those EC2 images, you can encrypt your EBS for encryption at rest. So that's how you would encrypt transit and rest with containers. I know I went over that super quickly. Usually that's a whole hour of talking about, but I hope that makes sense. Poll number 2. What is your primary interest in containers? Bring products to market faster, simplify app management, simplify app migration, or other? It's a good question. All right. Getting some heavy responses here. We have the majority right now, at least, is simplify application migration. Okay. We'll get into that in a second here. Other is killing it. Bring products to market faster. Very interesting. So while being difficult to address other, I could talk about the simplifying application migration while we get more answers here. Yes, it can certainly simplify application migration, because remember, you have all of your dependencies and frameworks and libraries, all that within an image, and you can just import that image into ECR, Elastic Container Registry, and then use code build to build the image and deploy to ECS, Fargate, whatever. So 100% makes migration easier. Simplify app management, you betcha. Different teams can manage different workloads. You don't have to all be on the same page all the time. Bring products to market faster, you betcha. Absolutely does that, because you don't have to worry about developing, syncing dependencies every time you want to come up with a new product or a new feature, so on and so forth. Okay, wow. Good responses. Thank you, Cody. Okay. So yeah, if your answer is other, throw it in there, and I'll try to address it. Let's talk about some case studies here. We only have a few minutes left, but the first case study that we did here at ClearScale is First Street, and essentially they were new to containers, and they wanted to be able to build and deploy container images in the most effective way possible to ECR to use with ECS. And so, as I said before, right, you can deploy images to the container instance or the task, but they were wondering, how do we build that? And this is where we incorporate CI/CD, continuous integration, continuous deployment with ECR. And so essentially, right, we pulled down application images, we developed the application images to put into ECR, but as we deployed them to the actual tasks, that needs to be done with CI/CD. More specifically, code pipeline, more specifically, code build and code deploy. That is how you build the image and deploy to the actual container. Remember that the container image is just an image. You actually need to automate the build of it, which you can do with a couple clicks of the mouse, because it has all that stuff already intertwined into packaged and ready to go in the image. But you have to build it with code build, and then you have to deploy it with ECR. I'm sorry, we have to deploy it with code deploy to the actual task that's live in your environment. And that's what we did for First Street. And so they were able to automate this whole process once they had the container image. As new container images were added to the ECR repository and they need to deploy, they would just do basically a git push It would launch the container image into code build. Code build would automatically build it, automatically do unit tests, which is super important for container images, or really any workloads. And then code deploy would take it, go through a manual process before it deployed to production, meaning that you just approve it within the code pipeline console, and boom, it would be deployed right to the task. It was very, very simple for the customer. And for those of you who are managing containers on premise, this is why I highly encourage you to go to AWS, is that so you can deploy and develop at a much faster rate than you can do on premise. Revitalize IT infrastructure. So Bloomreach had a very, very interesting case study for this. And so essentially Bloomreach already had containers in their environment. They had a small containerized environment, but they weren't fully sure what's happening within their containers. And so this kind of brings me back to the slide where I was talking about logging and monitoring with CloudWatch or FluentBit or FluentD. They had a Kubernetes cluster that they were concerned, why are we getting so much failures? What's going on in the application here that's that's causing latency, it's causing bottlenecks. I thought, EKS is supposed to handle all this and so on and so forth. And so they needed a way to dive in deeper for their workloads. And so what ClearScale was able to do is install FluentD on the tasks, feed those logs to a centralized logging group within AWS called CloudWatch Logs. From there, have a CloudWatch Logs subscription. So all the logs that hit CloudWatch Logs, and the subscription would push CloudWatch Logs via Kinesis to Amazon Redshift, which is a data warehouse for enhanced querying of those logs. And so this architecture we're able to give Bloomreach a tool and a way to dissect what's going on in their environment, in their containerized environment, with SQL-based querying into those logs, which is huge for enterprise customers, especially if you have a large enterprise application with hundreds or maybe even thousands of containers, right, in your EKS environment. You need a way to sort through those logs, right? Otherwise, you're never going to know what the heck is going on. And so this architecture for Bloomreach, which had thousands of tasks or containers, the logs had to be neatly organized. So we used, it was FluentD. Yeah, we used FluentD to push those to CloudWatch Logs subscription. And the CloudWatch Logs with log subscription, who was subscribing to the CloudWatch Logs group was Kinesis. Kinesis pushed those logs, which is a streaming service, pushed those logs to Amazon Redshift, which is a data warehouse, and they were able to query that based on however they wanted to view the logs and build dashboards and basically look at performance over time as it relates to different applications. I mean, they did all sorts of cool stuff with that logs. And so this is another reason why containers on the public cloud is really beneficial as opposed to on-premise, because you can do all these cool things as you grow and have all these cool query analytics. So that's it for me. Cody, I tried to keep it to 2 minutes. If anyone has any questions, please feel free to talk to us here at ClearScale and get in touch with me, or I'm more than happy to address anything that comes up. So I hope this was super beneficial for you guys, and thank you for the time.
Well, Anthony, we really appreciate you coming on and walking us through the differences in EKS, ECS. I know I still get confused whenever I'm hearing all these terms. So huge benefit for me personally. This was a great program. So thank you so much.
Thank you.
I'd like to remind our audience that this session was recorded. So following this panel, you'll receive an email with a link to access the recording on demand. You can also find it living on the DevOps website at devops.com/webinars, and be sure to look in the on-demand section. So at the top of the hour, I mentioned we had 4 $25 Amazon gift cards to give away. So our first winner is Tariq S. Our second winner is Jason M. Our third winner is Raj C. And our fourth and final winner is Sri G. So to the 4 of you, congratulations. Please keep an eye on your inbox to claim your gift card. But if you don't happen to see that email, just check your spam folder. I'd like to thank AWS and ClearScale for sponsoring today's webinar. And to our audience, we really appreciate you spending time with us today. We ask for one extra moment of your time to fill out a brief post-webinar survey, but otherwise, we do hope to see you at an upcoming Techstrong learning program. Everyone, have a great rest of your day. And Anthony, thank you once again.
Thank you. Good luck, everyone.